Alright guys, so we're gonna learn about database design, how to create scalable databases. So database tables, you've experienced a little bit when you've done MySQL. You learn how to do some queries, right? But how do you design the database? So all these took me a while. There are people that just specialize in creating database tables, but here in the video, I'm going to show you, break it down into something really basic. So database tables are just buckets, right? It's just buckets where we store information. So we may have a users table where we store all the information about the users, okay? So that would be called the users table. We also can, for example, in the MySQL exercise, we had another bucket or another table called leads, and in the leads table, we contain all the information of the lead. Now, there are a few principles in database design that's very important, and that is, I don't know how to explain this simply, but we want to keep things modular. Okay, we want to keep each database to be small as possible, and we want to keep it modular. I think that's the best way to do it. So let me give you a bad example. Okay, the bad example is you have one table that stores everything about everything. So for example, instead of having like say buckets where we store information about the sites that the users belong to, or another table called leads that has information of the leads of the user, and that has another bucket or table called users. A bad example is you have one table that stores all of that information in one table, and the table gets really big. There are a lot of new fields that you're adding. Also, there are a lot of different entries because for one user you may have like 10 entries. It's very inefficient, right? Imagine, one way that I think of database design is just think of an Excel spreadsheet. If you have like millions of records and you got one Excel sheet open, like that's information overload, right? But let's say you got an Excel file and then you got a tab. One's called the user, one's called the lead, one's called the site, one's called, these just maybe emails that were sent out to the users, right? If you have different sheets or buckets to contain kind of independent information, it's still linked but kind of independent, then makes it easier for us to see, right, as programmers. But also it's really nice for database because because if you break it down that way, the Excel sheet doesn't have to get very big. It can be very neatly organized. You don't need to create millions of rows with a lot of fields that are empty, occupying a lot of space in the database. Is pretty smooth. Okay. All right. So that's one of the principles when you design the database, to keep things simple, keep each table independent. Okay. And now there are also some naming conventions that we want to follow in all of our VillageADA. Okay. So one is the primary key needs to be called ID. Okay. Now the table name is going to be plural. So instead of user table, it's going to be users. Okay, leads, sites, clients, courses, chapters, modules. Okay, and all the primary key is going to be called ID. Now, when you have another table that references to another table, then for example, let's say I got a leads table, and in the leads table, I want to record the user ID. What I do is I do user underscore ID. That points to the ID field in the users table. Okay, that's it. That's how you do it. The table names are plural. The main primary key is called ID. When you reference that ID in another table, you do the name of the table in a singular form underscore ID. Okay, we always want to create at the end of the table created at and updated at. Created underscore at, updated underscore at. And it needs to be, each word needs to be broken down by underscore. Okay, that's just the naming convention. All right, so with that, another thing that's very important is you got to make sure that you're indexing the right fields. So if you're going to have a lot of queries where you do, like for example, where and then you say email is equal to something. Now, if email field is not indexed, and then you're going to be doing a lot of those queries where email is equal to whatever. If email is not indexed, let's say you got 1 million records, and you're doing a query that searches for an email address, it's going to search through all that 1 million records. It's going to take a lot of time. If you create a table and if you say email is going to be searched a lot, so I want to index it, then what it does is it creates an index file, maybe a few hundred megabytes, but makes it easier for the database to look up information and then find the information you need. So imagine, okay, in my previous example, I talked about where email is michael@villageidiot.com. There are millions of records. If the email field is not indexed, it's going to search all million records. Now, if I indexed the email field, then what it does is it looks at the index file and says, hey, give me all the rows that has michael@villageidiot.com. It looks up in that smaller index file, right, instead of millions of records, and then it says, hey, row 3 and 5 are supposed to be michael@villageidiot.com. So it just looks right there. It's really quick. That can make the database anywhere from 10 to hundreds of times faster just by indexing the field. Now, how do you know which fields you should index? A good example is you can record the slow query log, and you can configure the my.cnf file to record any queries that take more than, for example, 3 seconds. And at the end of the day, you can always review those query logs and see which queries are taking longer. And most likely, if you do proper indexing, then it will speed up the database. It's not just the database design, it's also how people write the query. If people write nested queries, it's also very inefficient. And that's why, in our MySQL training, we said do everything left join. And if you're using object relational mapper, sometimes you don't have to worry about that. Okay? All right, so again, big things to remember. The table names needs to be plural. The primary ID, which should be auto-incremented as well, should be called the ID. Okay, I don't know if I skipped some stuff. Okay, so the primary key should be called ID, created at, updated at, and then make sure you're using the right type, integer, big int, text, boolean. Is really important. I've seen some tables where they just use strings all the way throughout, and it's horrible. Why use varchar? Varchar is slow. Text is slow. If something can be done in tiny int or int, use integers. Okay. If you're storing Facebook user ID, you need to go big int because Facebook has too many users. Integer only handles, I think, a few hundred million, and Facebook has more users than that. Okay, so make sure you use the right type, and below I'm going to go through some examples. Okay, so that you can see how the database should be designed, and after you see some examples, it will be your turn to create the database entity relationship diagram using MySQL Workbench. Okay, all right, bye.